Hello friends, I'm Snehal Patil, Assistant Professor of the Pharmaceutical Chemistry Department, Swedish College of Pharmacy, Pundarpur. So today we discuss the saponification of the fat and the oil. This is the topic in the pharmaceutical organic chemistry coming under the analysis of the fat and oil. So what is the saponification? So definition of the saponification is when triglycerides, that is a fat or oil, are hydrolyzed, that is a saponification, by the alkalis, that is a base, alkali base, that is a NaOH or the KOH, and the formation of the glycerol and the salts of the free fatty acid, which is a producer from that fat or oil. So this sodium and the potassium salts, which are obtained the term, is called as a soap. And the formation of the soap, that is a salt from the fat and oil, that is a triglycerides with the alkali NaOH or the KOH, is known as saponification. That means simply the saponification, it is nothing but the process in which the soap is formed by the hydrolysis of that fat or oil with the alkali KOH. That process is called as a saponification. So why the saponification is needed? So saponification is used to testing the adulterations. Next is the higher amount of the oil, which is used for the making the soaps. Means the which oil is used to making the soaps. So the quality of that oil, the quality of the fat is checked by the saponification. So this is used in the analysis of the fat or the oil. So this is the reaction. This is the structure of the triglycerides. It is reacted with the three molecules of the NaOH and the formation of the glycerol and the sodium palmitate. Sodium palmitate is nothing but the soap. So triglyceride is a long chain structure. So for making or hydrolysis of that triglyceride, so three molecules of the NaOH or the KOH. If the NaOH is replaced by the KOH, then the potassium salt is formed. If the NaOH is used for the hydrolysis, then the sodium salt of that free fatty acid is produced. So that salt of the free fatty acid is nothing but the soap, and the formation of the soap, that process is called as the saponification. So this is a oil. Oil is come under the hydrolysis and the formation of the soap. Next is the saponification value. Saponification value is nothing but the number of mg of the KOH is required to the saponify the 1 gram of fat and oil. If you take the 1 gram of fat or oil and is reacted with the KOH solution and the formation of the soap, so how many amount of KOH is required to saponify that 1 gram of fat or oil? That nothing but the saponification value. So this saponification value is used to measure the average molecular weight of the fatty acid, which is present in that particular fat or oil. The principle behind this saponification value is a process by which fat acid in the triglyceride, any other fat or the oil, which are hydrolyzed by the alkali solution and the formation of the free fatty salt of the free fatty acid. This is the saponification. So procedure of the calculation of the saponification value. So firstly, take the two conical flasks, label as a test conical flask and the planned conical flask. First step is take the 1 gram of oil or the fat, which is used as a sample, and add into the test conical flask. The next is add the 10 ml of the ethanol or the ether in that first test conical flask and mixed well by the stirring by the stirrer, and that fat is well dissolved into that sample solvent, and that is ready for the reacted with the KOH. So next is the blank conical flask. In that there is no addition of the any sample. Then only the add the solvent solution, that is a 10 ml of ethanol or the ether, and mix well that ethanol or ether. Then in the both the conical flask add the 25 ml of the 0.5 normal KOH. Test also, and also the blank conical flask. Both the conical flasks are fitted with the reflect condenser and heated on the boiling water bath for the 30 minutes. After the 30 minutes, replace that conical flask from the reflex condenser and place for the cooling, for cooling the solution. After the cool the solution, add the 1 or 2 drops of the phenolphthalein indicator in both the conical flasks. Then it is titrated with the 0.5 normal SCl until the pink color of that phenolphthalein indicator is disappear, and this is the way there is a one point where the pink color is disappear. That point is nothing but the end point of that titration. Then take the reading of that burette where is the end point is found, and that reading is nothing but the A, small a. So small a is means what? So small a is nothing but the ml of SCl, that is a 0.5 normal SCl, is required to neutralize the excess of 0.5 normal KOH, which is present in the test sample. That means we already add the 25 ml, the 0.5 normal KOH is a solution in the both the conical flask. So we know the 25 ml of KOH is added into both the conical flask. So there is a if the reacted with the SCl, then means if the 20 ml of the SCl is required to neutralize the excess of the KOH which is present in the test sample, this is the nothing but the 5 ml of the KOH is required to neutralize the free fatty acid which is formed by the hydrolysis. So we know the excess of the KOH which is present in the test sample by knowing the how many ml of the 0.5 normal SCl is required to neutralize that excess of the KOH. So what is a blank? The next procedure for the blank, then same is take the reading for the blank solution, that is a B, and B is a nothing but same, that is a how many ml of the SCl is required to neutralize the 0.5 normal KOH, which is excess amount is present in the blank solution. Always the B has the more reading than the A, because in the sample solution there is in the blank solution there is no sample. So the 25 ml of the KOH is all the present as excess amount. So SCl is all the SCl is required for the neutralize that 25 ml of the KOH which is present in the blank solution. So next is the formula of the saponification value. The saponification value is equal to 28.05 into B minus A divided by W. So where is the W is a weight of sample in the gram, that is oil or the fat. B is a blank, that means the reading of the blank sample solution, and the A is the reading for the test the solution. So saponification value, that means the number of fat. Okay, so we measure the molecular or average molecular weight of that fat or oil. It is nothing but the mg of KOH is consumed by the 1 gram of the fat. Thank you, friends.